to this lecture, and we are continuing from where we left. And today's lecture is on network classification. We are on network classification, and we can classify networks in different ways. We can classify networks based on transmission media. We can classify based on network size, management method, topology, purpose, and or ownership. And here on size, we discussed this in a previous lecture. We're talking of we can classify based on local area networks, personal area networks, backbone networks. You can talk about wide area networks on our next slide, and metropolitan area network. Then when we're talking of local area network, I'm sure I discussed this in a previous lecture. We are talking of a network that covers a small geographical area, such as a home or office. Then utilizers are typically used for sharing resources, such as files and the printers. Then there is high data transfer rates. Then there is also personal area network. When we're talking of personal area network, we are talking of network that connects personal devices within a short range, usually few meters. We're talking of sharing between devices, such as transferring files between a computer and a smartphone. Then backbone networks, this is a high-speed network that links multiple local area networks at different locations. Then backbone networks are typically used in large organizations just to connect local area networks, and they provide high-speed data. When we are talking of wide area networks, this covers at least 10 kilometers. This spans large geographical areas. This is connecting multiple local area networks. Ones have lower data transfer rates compared to local area networks, and are typically used for connecting remote offices or branches. Then we are talking of a metropolitan area network. We are talking of those networks spans less than 10 kilometers. They cover a city or large campus. They connect multiple local area networks within a specific area. We talk of connecting LANs and BNs at different locations. They are also typically used for providing high-speed data transfer and connectivity within a metropolitan area. This is the diagram that can show when we're talking about local area network. Look at the first diagram, then the second diagram, metropolitan area network, then the backbone network, then the last one is the wide area network. So you can just look at the diagram so you see what I'm talking about. Then here we're going to talk about types of networks, and now based on ownership. And here we're talking about public and private networks. When we are talking of public networks, these are networks that are owned by service provider, and they are accepted to the general public. We are talking of the internet, right? They are also used for providing internet access to the public. When we are talking of private networks, we are talking of those networks that are organized, they're owned by organizations for internal use. Private networks are typically used for providing secure access to internal resources. Private network, we are talking of corporate internet. Our CAT Wi-Fi, CAT internet is classified as a private network, and they provide secure access to internal resources. It goes to our students, to staff in the company. Then also classify our networks based on purpose. purpose. And on purpose, we are talking about the intranet, the extranet, and also the VPN. And when we're talking about the intranet, we are talking of a private network that is within an organization for internal communication. For example, we're talking of insurance-related information provided to employees over an intranet, right? Then they are typically used for sharing information and resources within an organization. Then when you're talking of extranet, these are controlled private networks that allow access to external partners. They are used for sharing information and resources within external partners, right? Then this is open only to those invited users outside the organization, and they're accessible through the internet. There is an example that I gave, right, that suppliers and customers accessing inventory information in a company over a VPN. This is a secure connection over the internet that mimics a private network. They are used for providing secure access to remote networks. Alright. Then also our networks are classified based on connection methods. Here we're talking of wired networks and wireless networks. On wired, we are talking about use of physical cables. We discussed this earlier. We have Ethernet, fiber optics to transmit data. And examples include the internet networks and cable television networks. And on wireless networks, we are talking of the use of radio waves or infrared signals to transmit data. Then we talk of Bluetooth devices and cellular networks. These provide mobility and flexibility, but also may be less secure. Then here we're talking of classification based on functionality, and here we are talking of clients, safer networks, and peer-to-peer networks. And when talking of client safer networks, we are talking of networks that have a central server that provides resources and service to client individuals, right? To client devices. So central server provides resources and services to client devices. Here examples: corporate networks, where a server hosts applications. There's a web server that provides websites to clients. We're talking of a database server that provides data to clients, right? Then we can talk of peer-to-peer networks. Here, each device can act as both a client and a server, right? Sharing resources directly. Here we're talking of file sharing networks. We are talking of distributed computing networks. We are talking of peer-to-peer file sharing applications, right? Then you can also classify networks based on network topologies. We have star network, and on star network, we are saying that all devices are connected to a central hub, right? Star networks, they are used in large networks where a central hub is needed to manage a communication. From the word star, there is a central hub at the center, and also the devices that surround this central hub, like a star. I'll show you the picture later. Then also there is a bus network. A bus network is saying that all devices share a single communication line, right? Like a bus. I will show you the pictures. So, but they're used in small networks where devices need to communicate with each other. Then we can talk of a ring network. Then each device is connected to two others, right, forming a circular pathway, right, like a ring, the word itself. So they are typically used in high-speed networks where data needs to be transmitted very quickly. Then on mesh network, each device connects to multiple others, like a mesh, right, providing redundancy. So mesh networks are used in critical networks with high availability, where high availability is needed, right? So we need to move on to see the components of a computer network. And here, this is a star that I'm talking about. And you can see that there is a national interface card. There is a hub. There are switches. There's a modem, a router, and then there's the cables and connectors. Then we also need to look at the purpose of each component on the diagram that I showed you. And before we move on, maybe you need also to just write what you think about what you know, what you think are the purpose of each component. Also, we need to look at the components of purpose of each component. Purpose of each computer, each component that we have there. So, on the routers are responsible for forwarding the internet packets from one subnet or network to another. It's a networking device that connects multiple networks together and routes traffic between them. And we're talking of connecting multiple networks such as LANs and WANs. They route traffic between networks based on IP addresses and the network subnet masks. They provide network security features such as filing and access controls. Then to talk of bridges, these connects networks of different types. They're often CPUs or circuit cards in a PC. And also they connect two or more networks together at the data link layer. They filter traffic between networks based on MAC addresses. Then we also talk about hubs that are connectors for broadcast networks such as Ethernet. So they also connect multiple devices together in a network. And also they can provide a central connection point for devices also in the network. You can talk of switches, and also they are similar to routers but connect on LANs, usually the internet. You can also talk about modems, modulator, demodulator, a device that converts digital signals into analog signals for transmission over analog communication channels. And here we're talking about I used to connect devices to the internet or other remote networks via analog channels such as the dial-up or the DSL. They also convert the digital signals into analog signals for transmission over analog communication channels. And modems improve communication speeds and quality of analog communication channels. Then the network interface card, it's a hardware component, connects a device to the internet. You can connect computers or printers to a network, and there is a physical connection point for device to access the internet, the network. So we want to talk about the direction of data flow, and we have simplex on the slide, half duplex, and the full duplex. And on simplex, you can see that there is one arrow from the transmitter to the receiver. And on simplex communication, this is a one-way communication channel where data flows in only one direction from the transmitter to the receiver only. And I can give you an example for television broadcast where the TV station sends signals to the TV receiver, but the receiver doesn't send signals back to the station. On half duplex, you can see the arrow. There is a transmitter and also be a receiver. There is a transmitter here that can also be a receiver. And on half duplex, we're saying that it's a two-way communication channel where data flows in both directions but not simultaneously. They take turns. You can talk of a walkie-talkie where one person can talk while the other listens, but they can talk at the same time. Then there is the full duplex. You can see here on our slide that this is a two-way communication channel where data flows in both directions simultaneously. You can talk of a telephone conversation where both parties can talk and listen at the same time. This is the diagram. This is the transmission mode. Simplex only one direction. Then the duplex, there is under duplex there is half duplex and full duplex. And on half duplex, both directions, but in one direction at a time. Then in full duplex, both direction at the same time. These are network applications here. Application programs, operating systems, the data communication systems, the data management systems. These are the components of a network application environment. Then the major data communication applications that we have are listed here: the email, the group knowledge management systems, the e-commerce, the wireless application. And this marks the end of our lecture.